Dr. Aris Thorne, an atmospheric physicist whose career had stalled somewhere between groundbreaking theory and practical application, found himself in Fjordheim, Norway, not by choice but by a whisper of professional desperation. He'd come chasing an anomaly, a phantom sound reported with increasing frequency along the remote coastline, a deep, resonant boom, like a cannon fired in the sky, yet with no smoke, no flash, no discernible source. Locals called them sky thunders, ancient echoes of gods, or more recently, military exercises gone rogue. Aris, ever the scientist, suspected a rare atmospheric phenomenon, a unique convergence of conditions that warped sound waves into audible specters. His rented cabin, perched precariously on a cliff overlooking the glacial blue waters of the fjord, was a testament to Fjordheim's isolation. The nearest town was an hour's drive, the nearest city a plane ride. It was perfect for undisturbed data collection, he told his perpetually unimpressed department head. But after a week of setting up an array of infrasound microphones, seismographs, and meteorological sensors, the fjord remained stubbornly silent. The only sounds were the cries of gulls, the distant hum of a fishing boat, and the relentless sigh of the wind. He was beginning to wonder if his trip was merely a prolonged, expensive wild goose chase. Then, it happened. He was pouring himself a second cup of bitter coffee, the pre-dawn light barely sketching the outlines of the jagged peaks across the water, when a sound ripped through the silence. It wasn't just loud, it was physical. A colossal thud, as if a giant fist had struck the earth and the sky simultaneously. The cabin shuddered, a framed photograph of his late wife clattering against the wall. Aris froze, his heart hammering against his ribs. The sound was gone as quickly as it came, leaving behind an unnerving silence, a ringing in his ears, and the smell of ozone, or perhaps just his imagination. He scrambled to his equipment. The infrasound sensors had spiked off the charts, registering frequencies far below human hearing, yet clearly accompanied by an audible component. The seismograph showed a minute tremor, barely registering on the Richter scale, but undeniably present. The meteorological data, however, was stubbornly normal, no sudden pressure drops, no extreme temperature inversions that could explain such an acoustic event. Over the next few days, the booms became more frequent, varying in intensity and direction, but always originating from the same general area, the fjord itself, or the mountains directly above it. Aris started interviewing the locals. Old Gunnar, a fisherman with eyes as weathered as the fjord's cliffs, spoke of the fjord's grumbles. "They come and go, young man," Gunnar rasped, puffing on his pipe. "Always have. But never so many. And never so strong. The fish, they feel it. They go deep." Gunnar's words sparked a new line of inquiry. Could it be geological? Aris had initially dismissed seismic activity, as Norway wasn't known for major earthquakes. But smaller, localized events. He consulted geological maps, noting a complex network of ancient fault lines crisscrossing the region, long considered inactive. Yet, the seismic readings, however faint, were consistent. He spent weeks trekking through the rugged terrain, his equipment pack heavy on his back, placing more sensitive sensors closer to the suspected epicenters. He mapped the booms, triangulating their origins. The data pointed to a cluster of points deep within the fjord and along the steep, icy slopes of the surrounding mountains. The sound, he realized, wasn't just a boom, it was often preceded by a low, guttural rumble, a sound the infrasound sensors picked up far more clearly than his ears. It was like the earth itself was clearing its throat before shouting. One blustery afternoon, while setting up a sensor near a particularly steep cliff face known as Svalbard's Jaw, Aris witnessed something extraordinary. A low groan vibrated through the rock beneath his feet. He braced himself, his heart thumping. Then, a sharp crack echoed, not from the sky, but from the cliff face itself. A massive slab of ice, clinging precariously to the rock, splintered and crashed into the fjord below with a deafening roar, sending spray hundreds of feet into the air. The boom that followed was immense, shaking the ground so violently he nearly lost his footing. He rushed back to his cabin, replaying the data from that event. The initial groan, the crack, the ice fall, and then the massive boom, followed by a lingering infrasound signature. It was a breakthrough, but also a puzzle. The booms didn't always coincide with visible ice falls. There had to be more. He began correlating the booms with weather patterns, not just atmospheric pressure, but temperature fluctuations and precipitation. He noticed a pattern: the loudest, most frequent booms occurred after periods of heavy rain followed by a sudden, sharp drop in temperature, especially when the ground was already saturated. This was particularly true for the booms originating from the mountain slopes, not the fjord itself. Aris remembered an obscure phenomenon from his geology lectures: Cryoseisms, or frost quakes. These occurred when water-saturated ground froze rapidly, expanding and cracking the earth or rock, producing seismic tremors and loud booming sounds. Could Fjordheim's unique climate, heavy rainfall, sudden temperature drops, and a network of ancient, fractured rock, be a perfect breeding ground for these events? But what about the booms originating from within the fjord? The underwater sensors were picking up powerful acoustic signatures, sometimes accompanied by small tremors. The water itself was an excellent conductor of sound, and the deep, narrow fjord could act like a giant resonating chamber. He hypothesized that similar rapid freezing or geological shifts were happening underwater, or perhaps pockets of gas trapped beneath the seabed were suddenly released due to pressure changes or minor seismic stresses. He decided he needed to witness an underwater event firsthand, or at least get closer to its source. Gunnar, hearing of Aris's new theory, reluctantly agreed to take him out on his fishing boat, the Sea Serpent. "Crazy talk, Professor," Gunnar grumbled, his eyes scanning the gray skies. "But the fjord, she's full of secrets." They motored out to a particularly deep section of the fjord, where Aris's sensors consistently pinpointed activity. The air was still, heavy with the scent of salt and pine. Aris deployed a specialized hydrophone array, its cables snaking into the dark water. He watched the readouts on his laptop, a knot of anticipation tightening in his stomach. Hours passed in silence, save for the lapping of water against the hull. Gunnar dozed, his pipe cold in his hand. Aris was about to give up when a faint, low hum began to register on the infrasound display. It grew steadily, a deep, resonant vibration that seemed to emanate from the very depths of the fjord. He felt it in his teeth, a bone-rattling thrum. Suddenly, the water around them erupted. Not with a splash, but with a colossal, violent heave. A vast bubble of dark water, several meters across, broke the surface, hissing and churning like a cauldron. A deafening crack ripped through the air, vibrating through the boat, through Aris's very bones. The sea serpent rocked violently, nearly throwing him overboard. Gunnar awoke with a gasp, his eyes wide with terror. The sound was immense, a combination of a thunderclap and a deep, guttural roar, amplified and distorted by the water. It was the sky thunder he'd been chasing, but it hadn't come from the sky. It had burst from the depths of the earth, through the water, and then echoed off the fjord's towering walls. As the last echoes faded, leaving a profound silence and the acrid smell of disturbed sediment, Aris stared at his equipment. The seismograph showed a clear, sharp spike. The hydrophones had registered an unimaginable pressure wave. And the infrasound sensors had captured the entire prelude and aftermath. He understood now. It wasn't one phenomenon, but a symphony of natural forces, each playing its part in Fjordheim's mysterious chorus. The sky thunders were not from the heavens, but from the very core of the land and sea beneath them. The ancient whispers were the earth's own voice, speaking in booms and rumbles, a language that Aris Thorne had finally begun to decipher. The truth revealed. The mystery of Fjordheim's sky thunders is a real-world phenomenon known as Skyquakes or mysterious booms. These unexplained, loud sounds, often described as distant cannon fire or thunder, have been reported globally for centuries, baffling scientists and locals alike. Dr. Aris Thorne's investigation reveals that in this particular fjord, the booms are a complex interplay of several natural phenomena, primarily, 1. Cryoseisms, frost quakes. These occur in regions with cold climates where water-saturated ground freezes rapidly. As water turns to ice, it expands with immense force. If the ground is already fractured or weak, this expansion can cause it to crack and rupture suddenly, creating a booming sound and localized seismic tremors. The crack Aris heard before the ice fall, and the booms linked to sudden temperature drops after rain, point to this. 2. Shallow seismic activity *. While Norway isn't known for major earthquakes, minor, unrecorded seismic events can occur along existing fault lines. These small tremors, especially if very shallow, can generate low-frequency sound waves that travel through the ground and air, creating audible booms and accompanying ground vibrations. The underlying geological structure of the fjord, with its ancient fault lines, makes this a contributing factor. 3. Underwater gas release *. The most dramatic event Aris witnessed, the violent heave and vast bubble from the fjord's depths, points to sudden releases of trapped gas, likely methane, from beneath the seabed. Geologically active areas or areas with significant organic deposits can trap pockets of gas. Changes in pressure, perhaps triggered by minor seismic activity or cryoseisms, can cause these pockets to rupture and release explosively, creating immense acoustic energy that travels through the water and into the air. The deep, narrow fjord acts as a natural amplifier, resonating the sound. 4. Atmospheric acoustics *. While not the primary cause of the booms, specific atmospheric conditions, like temperature inversions or unique wind patterns, can refract, focus, or amplify existing sounds, making them travel further, seem louder, and obscure their true origin. This explains why the sounds could sometimes appear to come from the sky. In Fjordheim, these phenomena combine to create a symphony of natural sounds, each contributing to the mysterious sky thunders. It's not one single cause, but a dynamic, synergistic process driven by the unique geological and climatic conditions of the region.